Here we go again. Today we're talking about theoretical probability. Math joke. It's time for a joke. Question. What's the probability of a coin landing on heads 20 times out of 100 trials? Answer. A lot higher than the probability that I'll stand around to find out. Lesson 10.6. Two objectives today: determining the theoretical probability of an event and converting between probabilities and odds. Sometimes we hear those used interchangeably, but we're going to be talking about how to convert from one to the other. Our vocabulary: equally likely, theoretical probability, fair, complement, and odds. You need to look those up in your book if they are not easily accessed in your brain, in your gray matter. You might want to write those down for the test. When the outcomes in a sample space of an experiment have the same chance of occurring, they are said to be equally likely. Let's look. Equally likely outcomes. Each of these sections has the exact same area. They are each 1/4 of the circle. There's the same chance the spinner will land on any of the colors. In the case on the right, they are not equally likely. Blue has a 50% chance of occurring, red 1/4, and yellow and green each 1/8. Theoretical probability of an event is the ratio of the number of ways the event can occur to the total number of equally likely outcomes. Excuse me for botching that. Theoretical probability is the number of ways the event can occur over the total number of equally likely outcomes. Equally likely. So back to the spinner, the one on the left had equal outcomes. An experiment in which all outcomes are equally likely is said to be fair. You can usually assume that experiments involving coins and number cubes are fair. Let's look at example 1, part A. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome. Rolling a 5. There's one way it can occur, and each of the outcomes are equally likely, so there's 1 out of 6. We take that 1 out of 6, convert it to a decimal, and then into a percent. The experiment consists of rolling a number cube. What's the equally likely chance or the theoretical probability that we roll an odd number? Well, half are odd. 1, 3, and 5. There are 3 out of 6. And that's an easy one. We know we have 50% chance of rolling an odd. What's the theoretical probability of rolling a number less than 3? Not less than or equal to. There are two numbers, 1 and 2. So 2 out of 6, or 1 out of 3, 33.3% chance. You guys try this one. An experiment consists of rolling a number cube. Find the theoretical probability of rolling an even and rolling a multiple of 3. Come right back and we'll check your answers. And so we look at an even number. That would be just like the odd number problem. Even numbers are 2, 4, and 6. There are 3 of them. 3 out of 6 equally likely outcomes. So we say the probability, the theoretical probability, is 1/2. Remember, we're not running an experiment. We're talking about theory. And rolling a multiple of 3, we have a 3 and a 6. There are 2 multiples, and we're going to find that as 2 out of 6, or 1/3. Again, 33 and 1/3%. Learning how to read the notation for probability. The probability of an event can be written P parenthesis event. P heads means the probability that heads will be the outcome. The probability of heads is how we read that statement. When you toss a coin, there's 2 possible outcomes, heads or tails. The table shows the theoretical probabilities and experimental results of tossing a coin 10 times. Here's the experiment. The probability of heads, there were 3 out of 10. The probability of tails is the remaining 7 out of 10, of course. So if we add the two together, they should equal 1. 100%. Something had to happen, either heads or tails. They all add up to 1. In theoretical probability, now, we're not flipping the coin. We're just saying, in theory, what should happen? Half the time heads, half the time tails, and those as well add up to 1. The sum of probability of heads and the probability of tails is 100%. That's because it's certain that one of the two outcomes will always occur. The probability of the event happening plus the probability of the event not happening is 1. Now we're going to talk about the complement. I'm in the middle of 735 here. The complement of an event is all the outcomes in the sample space that are not included in the event. The sum of the probabilities of the event and its complement are always 100 because the event will either happen or not. So we say the probability of the event plus its complement is always equal to 1. We're finding the probability by using the complement now. A box contains only red, black, and white blocks. The probability of choosing a red is 1 out of 4. Black is 1 out of 2. What's the probability of choosing a white block? Either it will be a white or it won't. So the case where it won't is it's red and black. We know these two probabilities to be 1/4 and 1/2. 25% plus 50% plus something has to equal 100. So we do that quick math and we see that we have a 25% chance of white. You guys do check it out, number 2. See what you get. Come right back here and we'll check it. So we can see in this problem now, instead of blocks, we've got some marbles. We finally found our marbles. How exciting. I know some of us have lost them over the years, but now we know where they are. They're all in this jar. The jar has green, blue, purple, and white. The probability of green is 20%. The probability of blue is 30%. And purple is 10. What's the probability of choosing white? Well, it has to make up the entire 100%. So it'll either be white or it won't. This is the probability that it won't. So we're going to take all of those, add them up, 0.2, 0.3, 0.1. We've got 0.6. The remainder, or the complement, needs to be 0.4. The probability of white is 0.4. In a separate vein, we're going to talk about odds. They're closely related, but we have to get the fine details about how they differ. Odds are another way to express likelihood. Odds express likelihood by comparing the number of ways an event can happen to the number of ways it can fail. Not the total, but can happen, can't happen. The odds in favor of an event describe the likelihood that it will occur. The odds against describe the likelihood that it won't occur. Odds are usually written with a colon, A, B, A colon B, but also can be written A to B, A to B, or A over B as a fraction. The odds in favor of an event, the number of ways the event can happen, the number of ways the event can fail to happen. The odds against an event, the number of ways it can fail over the number of ways it can happen. A represents the number of ways the event can occur, while B represents the number of ways an event can fail to occur. Two numbers are given as the odds will add up to the total number of possible outcomes. You can see this relationship to convert between odds and probabilities. You may see an outcome called favorable. This does not mean that the outcome's good or bad. It just means that you're looking for it in your probability in the experiment. The probability of rolling a 2 on a number cube is 1 out of 6. What are the odds of rolling a 2? Here's where the difference comes to light. This is the probability. There are 6 ways to roll. There's only 1 2. But now we're going to talk about the odds. The probability of rolling a 2 is 1 out of 6. There are 5 unfavorable outcomes and 1 favorable. So the odds are 1 to 5. I want you to notice one way to happen, 5 ways to not, that happens to add up in probability to the total sample space. The odds in favor, the ways it can happen, over the ways it can fail. 1 to 5, odds in favor, 1:5, 1/5, or we could also write 1, the word 2, T-O, and 5. Converting between odds and probabilities, the odds in favor of winning a contest are 1 to 9. What's the probability of winning the contest? Here's how we learn how to convert. The odds in favor are 1 to 9, so the odds against are 9 to 1. This means there's 1 favorable outcome and 9 unfavorable, for a total of 10 possible outcomes. The number of ways an event can happen, 1. The total possible outcomes, 10. So we refer to that as 10%. The probability of winning the contest is 1 out of 10. The odds against a spinner landing on red are 2 out of 3. 2 to 3. What's the probability the spinner lands on red? So the odds against are 2 to 3. So the odds in favor are 3 to 2. This means there's 3 favorable outcomes and 2 unfavorable, for a total of 5. So we convert that, the number of ways the event can happen, that's what we did right up here, favorable, 3 to 2. There are 3 out of our total number, 5 ways. So there's 5 segments on the spinner, 3 of which are red. The odds in favor of winning a free drink are 1 out of 24. You guys find the probability and come right back here and we'll check it out. So we say there's one way to win a free drink. The odds in favor, the odds against are 24 to 1. So there's a total of 25 ways that we could possibly have this outcome. There's 25. If there's one way to do it, and there's 25 total ways, converting this to probability is 1 out of 25. And we say the probability is 1 out of 25, or 4 out of 100, or 4%. Here's your quiz. I want you guys to write these down, come up with the solutions, and then I want you to come back and check your answers. So this is just a little quick check to see how we understood the lesson. Number 1, randomly choosing B. Well, there's one way to do that, and there's 1, 2, 3, 4, 5, 6, 7, 1 out of 7. Theoretical probability, rolling a factor of 10 on a number cube. How many factors of 10 are on a number cube? 2 and 5 and 1. There are 3 out of 6. So we simplify to 1 out of 2. Probability it'll be sunny is 15%. Not is the complement. So 15 plus what is 100? That would be 85%. And the probability of choosing a red out of a bag of marbles is 3 out of 10. What are the odds in favor? Remember, this says the whole way, the number of ways, we can take a marble is 10. If 3 are red, then 7 are not. So 3 to 7 are the odds in favor of choosing a red marble. So that completes lesson 10.6. Please look to find your problem set, and good luck.